Hey guys, this is Fractions Day 3, and today we are done with our operations review and we're going to be starting division of fractions. Okay, so this is a new concept, so I want everybody to make sure that they're writing everything that I write and that they're staying on pace with me. Do not jump ahead in this lesson like you like to do sometimes. So let's go ahead and get started. So the first thing that you need to know is that division is the inverse of multiplication, and what that means is that it's kind of like the opposite. So we say division is the inverse of multiplication. That's going to be important to know when we get to working some problems. So let's run through a couple just hypothetical examples. Say you have a dozen cookies to hand out at a party for hungry sixth graders, and you plan to give each person 2 cookies. How many people at the party would get cookies? Okay, so you have 12 cookies. You're going to give each person 2. How many people would get one or get 2 cookies? Obviously 6 people, right? So you would divide 12 by the number of cookies each person would receive, and you would be able to feed 6 students. Okay, so there's a little model for you. Okay, now let's say more people than you expect show up to your party, and you want to make sure everyone gets a cookie. You still have 12 cookies, so you decide to give each person only 1. How many could you serve? So now our problem is to divide 12 cookies by the number each one would receive, which would be 1. So 12 divided by 1, of course, is 12. So you could serve 12 students. Okay, now let's pretend that we are throwing a party for supermodels who will only eat 1/2 of a cookie. How many guests can we serve with 12 cookies? Remember, each person is only now going to eat 1/2 of a cookie. So our problem is 12 cookies divided by the number each person will eat, 1/2. So 12 divided by 1/2. And look at that. We are going to be able to serve 24 people. So now this brings us to what is confusing with division by fractions. When you divide by fractions, when you divide a whole number by a proper fraction, you are going to end up with a number that is bigger than the original number you started with, or the dividend. So that should be in your notes. Actually, I take it back, it's not in your notes. But right now, let's stop and let's take a look at where it says Roman numeral 1 concept. It says Sammy bought 3 oranges. He cut each orange into halves. How many pieces of orange did he have? Go ahead and on your notes, go ahead and just divide each of those 3 oranges into halves, okay? Now, how many halves do you have? You can see from what you just drew that you have 6 halves. So that's our problem. The question that we're asking is, what is 3 divided by 1/2? And the answer is 6. So you should write an equals 6 there in your notes. Okay, now let's talk about, oh, there's the model for you. Let's talk about the process. How are we going to solve these problems? Well, the algorithm that we're going to use looks a little bit complicated in your notes, but it's actually really easy. So the first thing we're going to do is leave the first fraction or whole number. Then we'll replace the division sign with a multiplication sign. We will reciprocate the second fraction, which means to flip. We'll use cancellation to simplify if possible. Then we're going to multiply numerator times numerator and denominator times denominator, just like we normally do with fractions. And then finally, we'll simplify the answer. This process is called copy-dot-flip. The reason we call it this is because those are, in a nutshell, the steps that we're taking to solve these division problems. We're going to copy the first fraction or whole number. We're going to write a dot instead of a division sign that stands for multiplication, and we're going to flip the second fraction, and then we just multiply. Let me show you what I mean. Let's do a couple example problems. On your notes you have 3 divided by 1/2. Okay, now we learned back when we were doing our cookie examples that the question that we're asking when we're asking a division question like this is how many halves can come out of 3. So if you can picture that in your head, 3 oranges or whatever, splitting those oranges into halves, how many halves can come out of that? So it's the same as multiplying 3 by 2. So now here I've got my process that I've done. So I have copied the first number, 3, and I just went ahead and changed that to a fraction just to make it a little bit easier since we're working with fractions here today. But copy the first number, 3, then I wrote a dot, and in this case I wrote an X, but it's the same thing. It's a multiplication sign. And then I flipped the fraction. So instead of 1/2, I've now inverted that to 2. And then we just complete the multiplication. 3 times 2 is 6, 1 times 1 is 1, so I end up with an answer of 6. Let's do the second one. 2 divided by 1/3. Again, I'm asking the question, how many thirds can come out of 2 wholes? So we'll copy it down as our first step. And we're going to go ahead and just change that to a fraction. 2/1. We'll replace the division sign with a multiplication sign. That's our dot. And then we'll flip the second fraction, and it becomes 3/1. So now our problem is 2 times 3, and the answer again is 6. Okay, so there's our question conceptually there for you. How many thirds are in 2 wholes? Okay, and finally our third problem is 5 divided by 1/4. So again, our process is to copy the first number, so we'll write 5, and we change the division sign to multiplication. That's our dot, and then we flip the second fraction, and that becomes 4/1. So now our problem is 5 times 4, which is 20. Now if we were to visualize that and ask the question, how many 1/4 are in 5, we can see that we would get 20, right? So it's exactly the same as asking, what is 5 times 4? Okay, let's do another one. Now we've got 1 divided by 1/4. And we're going to go ahead and we're going to finish this, and then I'm going to have you model it. So 1 divided by 1/4, again, is we're going to copy that first number, 1. We're going to write a multiplication sign instead of a division sign, so there's our times, and then we're going to flip the second number, and that becomes 4. And of course the answer is 4. So on your sheet of paper you have a box, and what I want you to do is split that into fourths and then answer the question, how many fourths are there in one whole? And you should come up with 4, right? Here's a fourth, here's a fourth, here's a fourth, here's a fourth. How many are there? There are 4 in one whole. Okay, now our last one, 2 divided by 1/5. Oops. 2 divided by 1/5, we'll copy the first number, then we'll change the division sign to multiplication, and then we'll flip the second number, and our problem becomes 2 times 5, which is 10. And on your notes you have bar models, and it says underneath how many fifths are in 2 wholes. Go ahead and split each one of those bars up into 5 parts, and then count and make sure that you have 10 fifths in those 2 wholes. Should look something like this. All right, now you have a few Toyos, numbers 6 through 11. Go ahead and do those, and then come back and we're going to do the next few together. So do the Toyos, do the copy dot flip. In all of these you're dividing a whole number by a fraction, so it's exactly the same as what we just did. All right, let's move on. Now you've got, your task is to divide 1/2 by 4. Okay, so now we're dividing a fraction by a whole number. So this is a little confusing, isn't it? It's the same process though. So we're going to do exactly the same thing. We're going to still copy dot flip. So on my model here, make sure you copy my model. I've got 1/2 marked off. Okay? So I'm going to show you on the model why this works in just a second. But let's do our copy dot flip. So we copy the first number, so 1/2 stays 1/2. Then we change division to multiplication, and then we flip the second number. Now remember that when we have a whole number, the inverse of that whole number is going to be, 1 over whatever that number is, because normally the whole number in this case 4, it would be 4/1, right? So I end up with 1/2 times 1/4. So remember my division question over here, we could phrase that to say, how many 4 wholes are in 1/2? Well, obviously not even 1, right? Because 1/2 is less than even 1 whole, so there's only going to be like a fraction of 4 wholes in there. So let's go ahead and let's multiply that. 1/2 times 1/4 is going to equal 1/8, right? And then let's see why this works. If we divide 1/2 by 4, that's the same as multiplying by 1/4. When we multiply by 1/4, we're basically sectioning up that whole into fourths, right? And so if we're asking the question, what is 1/4 of 1/2, or 1/2 times 1/4? One of those is going to equal 1/8, right? Because now we have 8 blocks in our model. Okay, so you have a bunch more Toyos. Go ahead and complete the Toyos. Remember to simplify and remember the process for dividing. And then your homework tonight is workbook exercise 1 and 2. Make sure you're working in the blue workbook because we're done with the pink ones. All right, that's it. Have a good evening.